Recording in progress.
What I do, da da do, da da do. What I do, da da do, da da do. What I do, da da do, da da do.
Ever since I was little, I liked building with Legos. I liked going out, building anything in the backyard.
I hope to design and research new products that would go out into the field.
With the constantly evolving technology
I want to be part of making it universal, simplifying systems to make a difference.
The world's changed with the digital tools. It's a different program. The tools have been there for a while, but now with Industry 4.0, the Industrial Internet of Things, connectivity, the data that the tools need are readily available. Companies are jumping all over the students with the tools. Very early on in 2011, we joined the Siemens Academic Partnership. It brought in the various tools. We integrated those into several classes. Feedback was immediate. We're hearing from companies saying, your students have heard of these tools.
I actually teach the mechanical drafting side of things, and we use the Solid Edge software. Joining up with Siemens, we have the higher-end PLCs, which we work all the way up through, from basic controls right up to the HMIs.
We work with TIA Portal, Siemens HMIs, PLCs. It's easy to understand. When we use TIA Portal, we're able to contact people from Siemens and get assistance when we need it.
It's critical to entry-level engineering success. A lot of my classes were using Siemens tools already. So graduating from OU and having that experience and having Siemens experience, I'm coming into the company already knowing how the software works because I had to take it at school.
It's great for schools, but at the same time, it's great for companies like Siemens. Our students know the software, hardware, they can find jobs, both at Siemens and other companies that use Siemens products.
The aging generation that is now retiring needs to be replaced. This is the new generation. They bring a new spin to different things. They have a lot better grip on technology, and hopefully we can bring everybody into the modern world that way.
Siemens, ingenuity for life.
And good morning, good morning, good morning, good morning. Morning everyone to our hear my voice. Good morning to our deans, professors, instructors, and students. For our students, for our participants, no? Can you please type good morning from, say, from Stanford IT, Makati? So by the way, hello, my name is Jerome Castañeda. So I'm the Business Development Officer of Stanford IT Learning, the training division of CIM Technologies Incorporated. So I will be your host for this. So this morning, let me share what will you expect. So today's agenda, we'll have opening remarks and introduction. So by yours truly, we'll just a small introduction of our company. Then I will introduce to you our distinguished speaker. So very interesting topic to talk about the future of alternative energy sources. Very timely topic in today's economic situation. Then it will be followed by our solutions specialist. We will share about the next generation product development for today's engineers, and even future engineers, just like you students. Then we will have our open forum, question and answer, together with both of our speakers. So please type your questions in the Q&A chat box so that our speakers can answer your questions. So then followed, we will have our promotions and announcements. So by the way, we will also be having giveaway. So stick around and be attentive. We'll be giving away Grab vouchers worth around 500. And then we will also be sharing with you later on the e-certificate links as well. And so now let's introduce our company. So who we are? So we are CIM Technologies. So we are one of country's pioneers, in technology solutions from both software and hardware. So for training, we are in the training Stanford. And we also provide technical support as well and services to the manufacturing and the AEC market, or the architecture, engineering, and construction industries. So we are 30, I think we're 30 year this coming December. No? So really to provide you with the world-class software and hardware solutions, so project management tools and computer-aided design, building information modeling, project management education. So all across the architecture, engineering, and construction, and manufacturing industry. So Stanford IT Learning is a training division of CIM Technologies Incorporated. Our aim is really to equip engineers, architects, professionals, and the academic, teachers, and students with the necessary industry skills, no, to maximize the use of our product design, computer-aided design, and project management software. So we provide you with the high-quality computer-aided design, project management courses. So with our highly experienced and certified instructors that really guarantee to meet your needs, industry needs of the industry. This is some of our valued partners to this. Of course, Siemens, no? Formlabs, our 3D printer hardware partner, and Oracle Primavera for project management. As well as we are also partner with Dell and HP for the hardware. So what we offer here at Stanford IT is we provide classroom-led type. We also, of course, we have our classroom and also on-site services. And of course, now in the pandemic, we do have a lot of online training via Zoom, MS Teams. So we also can customize our trainings according to your needs, to the industry. Okay. Next. So training courses are, of course, I mentioned already our partner, Autodesk, Solid Edge, our main product for today, and Oracle Primavera, our project management software. So we also provide services. So by the way, we have our services called Pantheon 3D. They also provide CAD drafting, BIM services. No? So we also provide product design, 3D modeling or reverse engineering, that's scanning, and also provide 3D printing modeling as well. And also large models or large format scanning and printing as well. Okay, so I already mentioned, so some of the software from the AEC, AutoCAD, no, and Civil 3D and the rest. So these are Autodesk. And also the hardware that I mentioned, primarily Dell and HP. Of course, we have the support that we provide as well. We are being certified by both Dell and HP. So of course, the training and the other application support as well. Okay, so let me introduce our main speaker. So he is a licensed mechanical engineer. He's currently taking Masters of Science in Construction Management at PUP. He's currently working at Polytechnic University of the Philippines, Innovation Office as engineer. Among the projects he is involved with are the establishment of PUP Engineering Advanced Technological Training Center, together with CHED, and the PUP Fab Lab, Fabrication Laboratory. So the other projects he is involved with is the novel material as anode and cathode for power generation aluminum air reactor, with sponsored by DOST, and synergistic air and water quality sensing system with purification devices using local materials for the MSMEs. So this also by DOST provide sponsored. So without further ado, so let us give a warm welcome to Engineer Jhon Helarch Antoni. So let us send a virtual clap to Engineer Antoni.
Good morning, everyone. Let me share my screen. Nakita na po ba? Naririnig po ba ako? Malinaw po?
Yes,
Good morning po. Yes po. So, I am Engineer Jhon Helarch Antoni po from PUP Manila. I'm a technical expert po sa ating innovation, intellectual property management office po ni PUP. So, and also I'm a project researcher as well as a part-time faculty sa mechanical engineering department. So, I will discuss to you today the future of alternative sources, or we will from the conventional sources or non-renewable energies to renewable energy sources po natin. So as of November 15, based on DOE or Department of Energy, the total adjustment stand a net increase po sa ating price of gasoline or fuels is 18.15 per liter po sa ating gasoline, 36 pesos per liter po sa diesel, and 29.95 per liter po sa ating kerosene. This is based po sa ating Department of Energy status report po. So, bakit ko po na-introhan ng ganito po agad? Because ngayon po sa our status here in the Philippines, medyo nagso-shortage na po, or nagkakaroon na po ng shortage when it comes to electricity or energy distribution here sa different locations po sa ating country. This is due to our also due to the export and import of fuels and other materials used for electricity generation po. So nagkakaroon na rin po ng shortage yung mga na-import natin, and also nag-i-increase na rin yung mga price, and meron na rin po na the Philippines is facing a mounting energy crisis as Malampaya natural gas field is expected to be depleted by 2024 based on ITA. So si Malampaya natural gas field po ay gumagamit or under po siya ng Shell. So gumagamit po yung nagde-deliver, siya po yung nag-supply sa Luzon ng fuels as well as natural gas for electricity generation and power distribution po here in Luzon. So unti-unti na po nauubos yung non-renewable resources natin, as well as here po sa makikita natin dito sa ating chart, no, mostly ng mga power plant po sa ating country here is ang source po ng kanilang fuel is coal and oil base, which is yung methane, diesel, and mga crudo po or kerosene. And natural gas like methane, butane, propane, etc. po. And only 35% percent po is nag-shift na po tayo sa renewable energy, which composed of solar, wind, and hydro electric power plants po. So as we can see here, our energy demand and supply po, as of 2020, may demand peak po ang Philippines na 15,282 megawatts, and yung total dependable energy na nai-supply po is 23,059 megawatts. So as you can see here, na may maintain pa naman po or nasusupplyan po tayo ng appropriate or enough energy to operate po yung ating country. But based po sa dependable capacity, based po sa ating mga power plants po, yung gumagamit po ng coal is producing 10,895 megawatt of electricity, wherein almost half po ng nagsusupply ng electricity sa buong Pilipinas ay gumagamit ng coal, and only 7,175 megawatts ang napoproduce ng renewable energy power plants po. So as the time goes by po, na bumababa, kumukonti po yung supply po natin ng ating non-renewable energy sources po, mas nagmamahal po yung price ng ating electricity, as well as nagkakaroon po tayo ng mga power shortage. So ano po yung mitigation ni government to cope up with this or ma-sustain po yung energy supply po para po sa country natin? So ginawa po itong Republic Act number 9513, or the Renewable Energy Act of 2008, wherein it provides the legal and institutional framework necessary for harmonizing policies on the development of renewable energy and technologies po. Excuse me po, medyo maingay lang po yung background since may nadaan pong trend here sa PUP. Hello. May I continue since may timer pala po tayo? Here po sa Renewable Energy Act of 2008, excuse me po. Yan. May I continue po?
Yes.
Sorry po for the noisy background po. May dumaan lang po talaga na trend. Yan, so may I continue po? This Renewable Energy Act of 2008 aims to accelerate the exploration and development of renewable energy resources such as, but not limited to, biomass, solar, wind, hydro, and geothermal, and oceans energy sources, but including po yung mga hybrid systems po natin to achieve energy self-reliance through adoption of sustainable energy development strategies to reduce the country's dependence on fossil fuels po. So, moreover po, it aims to increase the utilization of renewable energy by institutionalizing the development of national and local capabilities in the use of renewable energy systems po, and promoting its efficient and cost-effective commercial application by providing fiscal and non-fiscal incentives po. So itong Renewable Energy Act po ay nagpo-promote po hindi lang po sa ating mga business partners or sa industry na to come up with a renewable energy power plants, but also to our government agencies to conduct researches to have more on alternative or renewable energy technologies po. So what is renewable energy po? So renewable energy po ay comes from a natural sources that replace themselves more quickly than they consume po. So yun po yung came from our nature po, which is we harvest its stored energy and convert it into electricity. And alternative energy po is any energy derived from non-fossil fuel sources po. So an example po is nuclear and biomass and reactor cells are example of alternative energy sources po. So here are the example of renewable energy power plants po, which is solar energy comes from the radiation coming from the sun. The wind energy or wind power plants come from the wind. The hydroelectric power plants come from our water reservoir. Tidal energy power plant or yung ating conversion of wave into electricity, then biomass and geothermal po. So here are some examples of large power plant sa ating country. First is the Conception Solar Farm sa Tarlac po. So it generates 150 megawatts. So this solar farm ay nasa Concepcion Tarlac po. Then another one po is the Ambangal Mini Hydropower Plant which is located at Ifugao. The project leader of this power plant is Tokyo Electric Power Company or TEPCO. Excuse me po. So may I continue po? So next po is the Macban Geothermal Plant B or the Makiling this is Makiling Banahaw. So this is located between the boundary of Laguna and Batangas provinces po, which is producing an output of 460 megawatts po, supplying both uh, ele- uh, electricity sa Laguna and Batangas and other its local provinces po. Then the Burgos Wind Farm or sa Ilocos, which have a output of 150 megawatts. So ito po yung nakita natin sa or yung parang trademark po ng Ilocos, no, ng Ilocos Norte, yung wind farm po nila. So paano po ba or how alternative energy sources can affect society, economy, and environment po? So here, when it comes to society or our social impact po, renewable energy is way out of rising climate crisis. Energy availability can benefit livelihoods, health, and education, and additionally, it can considerably lessen the negative effects of air pollution, burning of fossil fuel on health of human health while also providing jobs in local communities. So kung marami pong renewable energy power plants po instead of uh, fossil fuel plants, we will have a greener or cleaner environment, as well as it produces more jobs sa ating community. Next po is sa environment. So using renewable energy as our sources will greatly reduce the carbon dioxide emissions and raising the awareness of climate change in public. So nababawasan po talaga natin yung ating air and water pollution, deterioration of our public health, water use and land use, emission that contribute to global warming po. So marami pong nare-resolve ang paggamit na or promote and pag-switch po sa renewable energy sources po. And when it comes to economy, since we will have our own or kaya natin i-sustain yung ating energy distribution or ating energy supply, our country will have an energy independence or hindi na po tayo mag-import ng fuels for for electricity generation, as well as stable energy prices, since wala po tayong using renewable energies is wala tayong fuel na sinusunog or na consume every power generation. So we will have more stable energy prices, then and grab job creation, reduce energy cost, and increase property value. So here po, so since alam na po natin yung impact ng renewable energy sources, and still we don't parang hindi pa po sapat yung pagpo-promote to or undergoing pa po yung pag-shift natin from conventional fuel, fossil fuel plants to using renewable energy sources po. So si DOST featured po, or the Department of Science and Technology, Philippine Council for Industry, Energy and Emerging Technology, Research and Development po, is nagagrant po ng research assistance in relation to their priority areas such as energy, transportation, energy, engineering, advanced materials and nanotechnologies, and etc. So as their way on promoting and mag-research pa or maka-discover or emerge ng mga bagong technologies in relation sa renewable energies, since papunta na po or nagshi-shift na po yung country natin or pinopromote na po talaga natin to have a better utilization of greener energy. So si DOST Fishered po ay nag-grant ng research assistance. One of the DOST Fishered project na ginrant po sa amin here sa aming university sa PUP is the aluminum air reactor po. So this is a reactor or battery that uses oxidation of aluminum as an anode and the reduction of oxygen at the cathode to form a galvanic cell po. So in the process of aluminum is completely consumed or minimelt niya po yung aluminum to produce aluminum hydroxide, as well as yung chemical reaction po form uh, uh, form a reaction wherein the electrons coming from the electrolyte or hydrogel electrolyte and aluminum harvest or collect as electricity. So here are some of our designs na dinraft and dinesign using solid edge software. So here is one of our prototype, which composed of several cells connected in parallel, and it is designed using solid edge software. So yung solid edge software allow us to design our prototype more faster but in a creative way, as well as may mga simulation wherein masa-simulate namin yung materials na gagamitin namin for our prototype, as well as yung heat flow or yung motion of heat, since we are focused on energy. We have a heat management here po sa ating research. So solid edge help us to realize those things in our research. So this is our actual experimentation wherein nag-fabricate po kami ng 12 volts 12 volts lithium ion battery pack with different capacity, and we charge it using our aluminum air reactor. So as of now, nakakapag-charge po kami at one setup ng up to 50 ampere hour of lithium ion battery pack po. And these aluminum air reactors will be used to charge or utilize in electric vehicle, as well as to charge phones and e-bikes and other technologies, and also serve as energy storage system po as one of energy source po na pwede natin i-contribute sa ating community. So another renewable energy that we have or currently discovering is the biodigester, or we use a parang what we call this, yung tirang pagkain sa mga fast food and uh, dinadigest niya and until it produce methane, then yung methane po yung i-harvest ng technology na to. So uh, this technology will help us to utilize our waste, our biological waste more uh, into more sustainable energy. So here is one of our prototype. So this is its key features. Then ito yung draft namin using solid edge. So ina-analyze namin yung bawat flow ng once na para flow ng methane production once from our digester to our container. So solid edge also use some features or simulate the pressure of tubes that can be used in a prototype. So to end my presentation po, let me end with a quote. A nation that can control its energy sources can control its future, by Barack Obama. So here, this is the end of my presentation. I hope you learned something from me, and let us promote renewable energy sources researches, and let us implement towards, and let us research and implement it for our future. Thank you very much po.
Yan, thank you very much, Engineer Jhon Antoni, and hope we are able to inspire our future engineers and even So before we proceed to our next speaker, so let us have our short trivia quiz. No, if you are indeed listening, so the criteria here is basically the mechanics is the fastest to answer. You get to a chance to win 3 grand vouchers worth 500. So if you are ready, can you type IR? Say I'm ready. Sige nga. So nagta-type ng IR. Walang sasali. 500 vouchers, Grab vouchers. So for our first question, what is the title topic? Di ba na we have my hello, can you see? I'll repeat hindi daw naintindihan dahil nag-e-echo. So we will have a trivia question, no? Just to ano lang, to spice up. So the fastest to type an answer will get the chance to win 3 Grab vouchers worth 500 pesos each. So if you are ready, can you just type IR, please, in the chat so I'm able to see if you are indeed participating or ready. O hindi nyo ba naintindihan? Yun. Thank you, Orlando. Ferdy, Noel. So, okay. Let's start. our first question. So ating first question, napakahirap na question. What is the title of the topic or the talk of Engineer Jhon? Ayun, the future. Parang binigay na yung answer sa ano ah. So sige, I'll just leave to our DTI representative. Si Abigail. I can still hear my echo. Congratulations. So for our second question, no? So if you are listening to myself kanina in the introduction, what is the course degree of our guest speaker? And hopefully you're listening to my introduction. Meh. Yun. Sige. I'll leave it to our DTI representative kung okay ba yung ME or mechanical engineer. So they decide. Leave it. So for our third question. So what is the name of the software that was used in the product design ng kanilang alternative energy? Kaya, mukhang si April lang na ako. Yeah, thank you very much for participating in our very quick trivia question. So let us proceed now to our next part of our program. So please let me introduce our next speaker. So he is a registered mechanical engineer and currently our solutions specialist here in CIM Technologies. He is a certified solid edge professional. So please let us all welcome, give a virtual clap to Engineer Leon as he shares the next product development for today's engineers. So congratulations to the winners.
Okay, so good morning everyone. So let me share my screen first. Okay, so welcome to next generation product development for today's engineers. But let me show you first a short clip featuring best of the best companies who are using Siemens Solid Edge for the past years. Right. So the video provides another view, no, of the diverse set of manufacturers who are using Solid Edge to improve their product development process. By the way, I'm Kenon Monleon, Solution Specialist for CIM Technologies. And here's my agenda for today. First is the Siemens overview. I'll discuss briefly why we partnered with Siemens. Then Solid Edge portfolio. So I'll discuss what's inside Solid Edge. And I'll also conduct a Solid Edge demo for us to understand the different functionality of Solid Edge. And I'll show you how to be a Solid Edge certified, and you can use these certifications as leverage when you apply for a job. Then finally, we'll proceed to Q&A portion. Let's begin with Siemens overview. Siemens success story begins with the pointer telegraph. The 10-man company called Telegrafen von Stalt von Siemens and Halks began operation on October 12, 1847 in a building in a backyard in Berlin. It's what we would call a garage startup today. Funding of Siemens is between Industries 1.0 and Industries 2.0. Siemens has played an important role in shaping industrial revolution since being founded in Berlin in 1847. Currently, we are now in Industry 4.0. And these are some of the milestones of Siemens throughout the years, especially with Industry 2.0 going to Industry 2.4.0. And in 2016, MindSphere introduced as the digitalization solution for all industries. Pioneering technologies and the business models that were built on them have been the foundation of Siemens for 170 years. And today, Siemens is a global powerhouse shaping the future and one of the largest companies in terms of footprint in the world. Being one of the world's largest producers of energy-efficient, resource-saving technologies, Siemens is a leading supplier of systems for power generation and transmissions, as well as medical diagnosis. In infrastructure and industry solutions, the company plays a pioneering role, and Siemens is number one, not by revenue, but in terms of most admired company in the world. Siemens is also a leader in STEM education globally. And Siemens is a corporation made up of several different and independent businesses. It is a conglomerate company. Siemens software is under digital industries and strongly focuses on the areas of electrification, automation, and digitalization. And for the past 15 years, Siemens invested more than 10 billion euros in bringing in new functionality. What you see, in fact, Siemens is one of the top 10 software companies in the world. Companies like UGS, Mentor Graphics, and Mendex are some of the companies that acquired by Siemens. And it also has a partnership with Bentley. Now let's proceed to Solid Edge portfolio. Every industry revolution, there is an exponential complexity. You'll see here the red circle indicates the degree of complexity for fourth industry. Industry 4.0 is the next step after the previous three industrial revolution stages, from water and steam power to mass production to electronics and automation. Industry 4.0 marks the next level of manufacturing with a focus on digitalized value chains. Any industry that looks toward the future is driven by innovation, striving to outperform their competitors. Companies are faced with increasing complexity across multiple dimensions, making products smarter by integrating mechanical with electronics and controls, ensuring quality while adapting new materials or manufacturing methods, taking advantage of opportunities afforded by the advancements in cloud and IoT. Compounding the situation are the conventional pressure of time, scope, quality, and cost. However, in the face of increasing complexity, these pressures are even more challenging to navigate. And this is the product life cycle management. Gray curve indicates the typical product life cycle. The objective is to shift the curve to the left, that is the orange curve. You are actually minimizing the design, cost, and time while increasing the market success and lifespan of the product. And to achieve the complexity of product life cycle, the solution is Accelerator. It is a portfolio covering all aspects of our product life cycle management. It also covers the product design, product manufacturing, and product performance. And we need to go digital to manage the complexity of our design. Accelerator helps customer to embrace complexity and use it as a competitive advantage. Now, Accelerator is Siemens' portfolio for digital transformation. And this is the summary of Accelerator from product design, product manufacturing, to product performance. And it is important to get the feedback from the product performance to determine if we produce a good result. And Solid Edge is part of Accelerator portfolio. Solid Edge is also a portfolio especially for mainstream engineering or small and medium business manufacturers, covering many areas for our product design from 2D, 3D, simulation, electrical design, analysis, and data management. It facilitates collaboration both within manufacturing companies and with external resources, including suppliers and customers. Now, Solid Edge is on the ramp to digital transformation. And Solid Edge is future-proof because it has many complementary products. One of the biggest technologies that Solid Edge has is a solid kernel, which is used by other CAD software on the market, and the exchange of data across different industries to be as seamless as or as little problem as possible. And by the way, it is owned by Siemens. Siemens developed technologies for Solid Edge. First is the synchronous technology. It is actually based from two different approaches, history-based modeling and direct modeling. Siemens combined these two methods and also added useful capabilities, and that is synchronous technology. And the second one is convergent modeling. It is a combination of BREP model and mesh model. We have the mesh model or facet model. Facet modeling represented surfaces as connected planar triangles, and surfaces were positioned to represent 3D objects. This method was preferred for its simplicity, but engineering accuracy required large data sets. And for the BREP or the boundary representation, historically, boundary representation used mathematically defined surfaces connected by topology to represent objects as watertight volumes. And today, most CAD/CAM systems for design, simulation, and manufacture of consumer and industrial products are BREP based. So we have developed a groundbreaking solution for convergent modeling. Our solution lets you use facet data in BREP workflows with no data conversion and all the benefits of both technologies. It also lets you work seamlessly with mesh-based models created using generative design and reverse engineering. So you can't really tell if you're working with BREP model or the mesh model. And now we have solution for different areas from mechanical design, electrical design, simulation, manufacturing, technical publication, data management, and cloud collaboration. Solid Edge is modular by design with progressing functionality. Together with additional add-on integrated application, now each module is designated according to the company's needs. And the most popular module is the Solid Edge Classic, and it includes the capabilities that the majority of our customers need for product design. And the next most popular is the Premium, which includes advanced applications like the electrical routing, piping, engine routing, stress analysis, and motion analysis capabilities. And now let's proceed to Solid Edge demo. And the product we're going to work on is from a customer master mover. Their products are all about moving heavy loads easily, be it a boat, wind turbine blade, or even a London bus. And this is the workflow we'll follow: part design, part drawing, legacy and imported data, assembly design, assembly drawing, and simulation. And this is our project to we're gonna redesign this clamp arm from scratch. And first up is part design, and what I want to focus on here is the real differentiator in Solid Edge, the synchronous technology. So here in Solid Edge, we have the ribbon bar. So ribbon bar consists the different commands that we're going to use in designing. And this is the pathfinder on the left side of our screen. We can also save configuration of hidden or shown parts to make it easier to work on different areas of the design. And we're going to be designing our part in the context of the assembly using the existing components to help speed up our design process. And to start the new part, we simply need to define the orientation and location of its origin. And then we can save the file name. Instead of starting our design with the sketch, geometry from existing components can quickly be captured and used as a basis for our new model. To create a cutout, and we can select multiple existing faces and use synchronous technology to push them all the way through the model. We can also manipulate the face of the geometry using the steering wheel. And by working directly with the 3D model, instead of having to sketch every feature, we can increase productivity and reduce the time it takes to create a prototype. And a single line can be drawn across a face, splitting it into multiple regions, which allow us to either add or subtract material. And in calculation, if a calculation is needed, and we can select few edges that we want to round and enter in the radius. Notice that we can select edges right through the part without the need to rotate it. And rounds are a great way to remove sharp corners or relieve stress concentration at sharp corners. And this is a type of procedural feature that can be easily edited if we want to. And dimensions can be added directly on the 3D model at any time to drive the shape and size of features or to help constrain the part and maintain our design intent. So we have an option here to select which driving end will move. We can also lock the dimension, and if we grab this geometry, we can move the whole geometry. So this dimension is unlocked. If we grab the face, we can either add or subtract a material. And then the next feature that we're going to create is cutout on the top of this face. So we are worried about the size of the sketch as we will add some constraint to the 3D geometry once it's created. And then after the drawing sketch, we can select the face relationships and and the depth of the cutout can be driven with an offset face relationship as well. So by editing one of the faces, we can see how Solid Edge is using the relationships to maintain the size and shape of the model. Now we want to add few more dimensions to tweak the size of the model. First, we will add a tolerance to the center bore, as this arm is meant to slide down the shaft and tighten into position. Tolerances determines exactly how much room for error you have when you manufacture each part. And we will add few more dimensions to parametrically change the 3D geometry. Because we created some of this geometry without the regards of exact dimension nga, we at any point can add 3D dimensions to finalize our design. So these dimensions and tolerances are for PMI, while in 3D, we're actually preparing for drafting. So we can retrieve these dimensions and annotations later on. And finally, we will dimension the slot width, and notice as we start to change the dimension, that both slots change as is our design intent to keep them the same width. And the next task is to add some mounting holes to attach the clamp mechanism to the arm. And notice all the different types of holes we can create from this easy interface. We will place the clearance hole on center with the outside round. And by using pattern command, we avoid the creation of holes over and over again. And let's make a drastic change to show you really how powerful synchronous technology can be. Let's tilt the entire arm by 5 degrees. And if this was a history-based CAD system, this would not be an easy edit to make. But with synchronous technology, we can simply select the arm geometry we want to adjust and rotate it freely to the required 5 degrees using the steering wheel. And the final step is to apply material. Solid Edge has built-in material library, and you also have the ability to add your own materials. And to summarize, we saw best of the both worlds modeling, the best of history-based and direct modeling, that synchronous technology, and the robust engine behind all of this is Solid. And this is so good, in fact, that it's used by many other CAD systems. However, what you might not know, it is owned by Siemens. But we keep the best bits for our own product. Synchronous technology is exclusive to Siemens software. Next up is creating a drawing of the part. We'll add variety of views to clearly communicate with our design, retrieve dimensions directly from the model, and finally add further dimensions and annotation to get it production ready. And to create our drawing, we're going to use what is known as quick sheet template. Using this type of template allow us to create drawings with a set of company standards, as well as retrieve associative dimensions and annotation automatically from the 2D model and place them on the 2D drawing views. And let's create a detail view to magnify small details of a design. A detail view is a partial generated view that shows only what is necessary in the clear description of the part. And if the detail circle location changes, the detail view will update, ensuring the correct information is displayed at all times. Another type of view that's popular is auxiliary view, which is best to dimension the cutout in the model. And auxiliary views are type of orthographic projection used to determine the true size and shape of inclined and oblique surfaces of part. And the next thing we want to add is some center marks. So it's as easy as selecting where you want to place them. Here we may want to have these center marks aligned with the edges of the part. And the center mark commands make it quick and easy to do that. Their basic purpose is to show the cylindrical or circular features in a drawing. Also, we want to add some center lines to areas that have side views of holes. Again, it's quick and easy to just select the two lines that make up the holes and place the center line. By using quick sheet template, most of our dimension were retrieved from the 3D model. But if needed, we can add dimensions ourselves. If we use the Smart Dimension command, Solid Edge will place the appropriate dimension based on the geometry we select. And one tool to do all those different type of dimensions. Next, let's create a feature callout. If we click on a feature such as one of these holes, you can see that it's extracting that information directly from the hole of the part. Now, Solid Edge can, of course, create your usual section views, but for our final view, let's create a broken out section. To create this, we scribe a spline here in the front view, then tell Solid Edge how deep we want to cut on another view. And finally, we can place the result in any other view. And notice how Solid Edge automatically places the correct hatch. And a broken out section view cuts away a portion of part in a drawing view to expose the inside. And to summarize, we saw fast view creation automated, production ready dimensions direct from 3D part with the ability to create further annotations tweaked to your requirements. And all of this clear and accurate to the standard you choose in Solid Edge, for example, ISO, ANSI, or etc. And next up, we'll look at how we can reuse legacy data and convert 2D drawings into 3D models. We'll also explore how to import geometry from another CAD package and work with it inside of Solid Edge. The first step of our create 3D command is to, of course, select the views that we want to use for 3D model creation. So dimension and annotations can be transferred as well. And our final step is to select a location where we want the views to be folded on top of each other, then move into the part environment. So synchronous technology allow us to work quickly. Simply can select some geometry and extrude it to a key point on another sketch. So no need to know the precise dimensions. While we begin to create our part, notice that the dimensions begin to attach directly to model, which save us from having to recreate work that has already been done and also give us the ability to edit and constrain our 3D model. And to finish up the model, we can quickly add a few rounds and primitive cylindrical shape to create a cutout. And as I mentioned earlier, all of the dimensions have attached to the model, which allow us to parametrically drive the shape and make changes. So notice as we make a change to this slot, the Solid Edge automatically maintains our symmetrical design intent and moves both slots simultaneously. And diameter and radial dimension can change easily as well. When we brought our legacy design forward, we did it so into a part environment, but we can clearly see that this is intended to be a sheet metal command. So we can simply convert this part into a sheet metal document and even generate the flat pattern needed for production. And now we can save our part. So next is we're going to open the part from another CAD package. So although we could simply select a hole to change its diameter, no, we may want to help future-proof this model by recognizing the holes as editable features. So thus allowing us to change things like the type of size of the hole as well as add threading at any time. Now, if you want to add your own dimensions, you can do this in 3D. So no need for sketch work. And we need to change the depth of the cutout to 50 mm. And notice the control, we have to keep the top face fixed. We can also change the diameter of the radius. And here we're simply remove any applied styles and stick with the solid edge part default. And after that, we can save this as a solid edge part. And to summarize, we saw how quickly legacy data can be converted to usable 3D models and how synchronous technology allow us to work with then solid edge data as if it was solid edge data. And transitioning and reusing data couldn't be easier. For the assembly design, so we need to assemble the legacy and imported parts we just created, as well as the clamp arm designed earlier. So in addition to assembling the components, we'll look at using the fastener system to place standard nuts and bolts into our assembly. So first, we need to isolate this sub-assembly. And we can easily locate the parts that we needed using the parts library in Solid Edge. And we can simply drag and drop the part inside the assembly, and let's apply some constraint, and the default relationship is in flush fit. So it applies the most appropriate relationship from mate, axial align, and planar align. Now we clearly see that we have a problem. We have a gap that we do not want. So typically we would need to measure the gap, then go back into the part and make the change to correct it. Instead, using synchronous technology, we can simply relate the faces together like we did at the part level, but right here at the assembly level instead. So simply select which face to move and which face to line up to. Now, if we rotate to a top view, we can again see that we have an issue. Our bracket is too large, but with synchronous technology, we can effortlessly make the needed edits. So first, let's edit into the bracket here in the context of the assembly, and then select the geometry we need to move and place the steering wheel in an appropriate location to make our move. And then we can simply line up our slot with the existing geometry, and Solid Edge will take care of the rest using design intent to keep everything aligned and symmetrical. And that's it for our bracket. Now let's proceed to the 3D imported data that we created earlier. And we need to edit in this assembly or sub-assembly. So as before, a simple drag and drop allow us to bring the component in and apply relationships. And the default part positioning tool, flush fit, we can automatically apply mate or axial align relationship based on the type of geometry we select. And we'll use that here to quickly position our part. And we need to place a mirror copy of our part on the other side of the model. So we can do this using the mirror command, which lets us choose if we want to place a rotated or mirrored copy of the part. Instead of dragging and drop the same part, mirror command makes it easier to place the part in exact location. And now we are ready to add the jaw to the clamp arm. And a couple of relationships will get that into the correct position. Now, it would be easier to assemble these components using the axial align from the assemble command to align two cylindrical axes. So notice how the hydraulic hoses automatically update to the new position. And on this part, we need some fastening hardware, bolts, washer, and nuts. And to achieve this stock, Solid Edge has the fastener system. So fastener system, we simply click on both sides of where we want this stock to be, and then the fastener system will automatically figure out what bolt sizes will fit these holes. Now we need to wait for a few seconds. So it is recommended to use a i7 computer. And we just need to wait for a few seconds or a minute. And what's left is to choose the standard type of bolt, what we want on the top stock, and a washer and and bottom stock, a washer and nut. And if we've used this same stock before, we can simply save it to use it again later, like we've got here. So very fast and very easy. So let's look at some options that can help speed up productivity on this next component we place in our assembly. So assembly relationships can be saved with the part file, so that when the part is placed into the assembly, as we're doing here, we only need to choose the faces or axis of the parts we want to constrain to. So no need to select anything on the placement part, which cuts our work in half. And another tool to help with part placement is our clone component command. So this command will place multiple occurrences of a part at multiple locations. So if needed, we can adjust each clone component and either flip, rotate, or suppress them. So the manual work involved in placing components repetitively can be avoided, boosting our productivity. So let's look at the caster assembly. We need to add another caster for the other side, fasteners and all. So we could mirror this. However, Solid Edge provides a quick way to copy components. So if you are used to using tools like Microsoft PowerPoint, so you'll know that you can simply select what you want to copy and then hold down the control key down while dragging to create. And then Solid Edge will even automatically create new relationships for these components to keep everything in place. All right, so to summarize, we quickly assembled our part into place with help from the automated fastener library, ensured fit and function as we went, and experience another great quality of synchronous technology, the ability for rapid top-down assembly work, blurring the line between part and assembly design. And for the assembly drawing, this is the same as creating part drawing, but we'll take a look at some assembly specifics such as exploded view and parts list. For the view, let's place an exploded configuration of our sub-assembly and shade in the view for a better look. And so to create an exploded view, Solid Edge has tools that look at the mating relationship of the components and then will explode for you, including flow lines. So now let's create a parts list with balloons. So you can save your company standard of what you want to show in your parts list. It is customizable. We can add size, mass, file name, material, etc. And parts list is usually combined with the assembly drawing as it provides a complete tabular list of all parts needed to build the complete assembly. And these balloons can help us to easily determine the parts. So we use balloons to label components with their item numbers from the parts list and to reference notes in the drawing. Ayan. So dealing with the balloons, Solid Edge has something called an alignment shape to control the distance from the balloons to parts. So we can also modify our parts list by simply double clicking it and apply some modifications. So we can change the font type and the spacing. And that's it for our assembly design. And to summarize, we saw how to place exploded views of our models. So we created automated parts list with balloons. And our next step is to check the strength of our clamp arm. So integrated into Solid Edge is a way to simulate this virtually. And because it's integrated, we can easily make any required changes and retest as needed. And we'll also look at documenting our results in the form of a report. So let's go to our assembly. So we need to open our sub-assembly, then isolate the clamp arm. And the next thing we need to do is to isolate and define our part using the simulation in Solid Edge. Then we need to do, the next thing we need to do is to add the load. So this is at the bolt location on these two holes. And we can use our trusty steering wheel to specify the direction the load is in. So we'll specify 150 newtons, as this is the force required to move our load of 800 kilogram, which the machine is rated for. So the next task is to add any necessary constraints to the model. So in this case, we need to add fixed constraints since it will be locked onto the shaft in the assembly. And our last step is to mesh and solve. So what does mesh and solve mean? Basically, what Solid Edge is doing is breaking our part up into elements, the element in finite element analysis, and then testing the loads and the constraint on each of these to give an overall result. It's then going to give us feedback on where the greatest stress is in the part. So here our results, purple is low stress and red is high stress. So we can even animate how the stress propagates through the part as the load is applied. So this is, however, just an exaggerated view to clearly show how the part will deform. So let's go to factor of safety. So we want this to be 4 times stronger. So we can notice here that it is below 4. So we need to edit our part, or we need to modify. So luckily for us, Solid Edge with synchronous technology makes this potentially complex changes very easy. So with a simple drag, we can update multiple parts and have the assembly update in real time to add a bit more material to the base of our part. And given the location of where the part would fail, let's also add more material to the round. And we're going to have to remesh and solve. So fortunately, there is no resetting up for the study. Solid Edge simulation provides the optimum default setting to allow us to run this complex study quickly. So let's wait for the results. So let's give our factor of safety another look. And factor of safety, then change the user-defined scale to 2 and 4. So by checking the minimum marker, we can see that the value is above 4. It is now 4.74. So the last thing that we want to do is to create a report of our results, and that's an easy single click create report. And as we scroll through, we can see all the results and even hot links of all the results with screenshots. So allowing designers the ability to quickly test their models and can greatly reduce costly simulation and prototyping times. Now let's switch over to the draft file we started earlier, and Solid Edge is telling me something is out of date. So let's update to see what's happened. So it tells me that there was a change to a few dimensions and annotations. And so let's click find to take me to the dimension. So, and that's it for our simulation. And to summarize, this is integrated simulation for design engineer use. So test for strength virtually to reduce physical prototypes, or if you're not worried about product failure, find out how much material you can remove from your product to reduce overall cost. And certainly worth noting, the technology used behind the scenes to ensure the accurate result is renowned FEMAP and Nastrans. Now, Siemens offers Solid Edge Student Edition. So this version is same as commercial license, but of course, file created here cannot be open using the commercial software. And the 2D drawing has watermarks. And by the way, this is free to any active student and should be used for academic coursework. So learning Solid Edge as part of your education prepares you to enter the workforce and helps you stand out in today's highly competitive economy. So this is the website or the link for the free software. For educators who have not yet applied for the academic institution bundle can download a free version of Solid Edge for independent study or classroom instruction. So you can easily access full Solid Edge portfolio of easy to learn and easy to use software tools for all aspects of product development process. Additional Solid Edge resources include educator training and problem-based learning curriculum and tutorials to support your classroom teachings. And Stanford IT Learning offers comprehensive courses of Solid Edge fundamentals and advanced. So they also offer guided learning path prepares students for certifications. And for the certification, we have 2 skill level for certification. So Solid Edge Mechanical Associate, intended for STEM students, and Solid Edge Mechanical Professional, intended for instructors, college students, or individual who have used Solid Edge extensively. And being certified boosts your resume with industry standards. So this demonstrates your proficiency and knowledge with engineering technology. So if you're a student, it may be leveraged as you seek internships, postgraduate employment, or tutoring gigs. And last December 2020, a community of professional designers, engineers, manufacturers, and students was launched here in the Philippines. So you may join by scanning QR code or search Solid Edge User Group Philippines. So this will enable you to learn and be updated about the best tools in Solid Edge or to get your skills discovered by potential employers. Now, Solid Edge is a key part of Siemens Accelerator portfolio and is focused on the requirements for small and medium manufacturers. Solid Edge enables manufacturers to create a comprehensive digital twin of their products and include solutions for mechanical design, electrical design, manufacturing, and technical publication. So it also includes solution for data management for all the technical data that is created and consumed when supporting the comprehensive digital twin. And it facilitates collaboration both within manufacturing companies with external resources, including suppliers and customers. And now Solid Edge is on the ramp to digital transformation. And here are the growing Solid Edge academic users. So we'll also starting here in the Philippines. So, and these are the customers of Solid Edge in Americas, EMEA, and Asia Pacific. So we also have customers for startups. And for more info, visit solidedge.com. And that's it for my presentation. Thank you.
All right, thank you very much, Engineer Kenon. So we proceed to our Q&A portion. Now we may invite our speakers. So Engineer Jhon and so for our first question for Engineer Jhon. Is Engineer Jhon around?
Yes po.
Sir, the question here is, which renewable energy sources is the best, or in terms of economical and more usage no, sa energy?
For based on my experience, sir, and based on my current researches, the best renewable energy sources that in terms of economic or an overall impact po sa ating country is solar and a combination or hybrid of solar and wind, and as well as yung hydroelectric power plant.
Wow, hybrid tatlo sir, solar, wind, and
No,
electric.
Since may mga deficiencies po kasi yung solar and wind energies natin, sir. May mga technologies po ngayon or mga emerging technologies wherein they combine those two energy sources. Sorry.
Right, thanks.
So, ayun po. So, that is one, I think one of the best. And for me, habang my life sa Earth, so solar and wind, or habang buhay po yung Earth natin, solar energy and wind energy is one of the best sources of electricity.
Right. Thank you very much, Engineer Jhon. Hopefully, more engineers will be inspired to do energy or alternative.
Yes, I hope
Also,
so.
perhaps they can also partner with you, no? Or
Yes po, our team or our laboratory here in PUP is open for collaborations, not only limited for renewable energies but other technologies po. So, um, pwede po na makapag-collaborate in terms of designing and prototyping. So, also, it depends po sa pangailangan ng also students or undergraduate students or other university with can share or collaborate with us po, with PUP.
Okay, thank you very much po. Sige, for our next question for ano naman kay Sir Kenon. So meron tayo dito sa Q&A box, no?
Yes, sir.
We can combine this question from Ronnie and so Solid Edge runs on what OS? Then I'll just combine this with what is the software's PC requirements, no, or hardware requirements? Does it run on the cloud?
Okay, so for the OS of the Solid Edge, so the required OS is Windows 10 or Windows 11. And for the hardware system requirements naman po, so it is recommended to use a Windows 10 Enterprise or Professional. So with a 9 gig of disk space for installation, 32 gig RAM or more. So 32 gig is the recommended, but for the minimum is 16 gig RAM. And for the screen resolution, 1920 by 1080, and then for the video RAM is 2 gig. So the other question is, does it run po ba sa cloud? So in Siemens, we have the accelerator share. So accelerator share is it's like a app na you can share your file, you can edit, so you can open it on browser on your PC. But yung tanong mo is yung Solid Edge, so hindi po. So kailangan naka-install siya sa PC mo po.
Okay, thank you very much. I hope that answers the question of Ronnie and the anonymous attendee po. So let's proceed po for the next question. There is another question for Engineer Antoni po. So sabi dito from Carlos, sabi, should the Philippines invest in industrial batteries such as those in California? Ano ba yung nandun sa California na battery? Yun ba yung kay Elon Musk?
Again po, sir?
Ito yung, should the Philippines invest in industrial batteries such as those in California? Ano kaya yung nasa California?
Hindi ko alam yung background ng industry batteries sa California, but I think we can produce our own batteries. May mga researchers naman tayo, and currently may mga institutions po tayo na may ongoing research regarding energy storage. So it includes battery management systems. So instead of investing sa ibang bansa, we hone our own product na gawa ng mga researchers natin.
Yeah. So let's support our engineers and scientists. Thank you very much po, sir. So there's another question, Ariel Glorioso po. As sabi niya dito, can you expound, Sir John, on how your design of your anaerobic digester produces methane faster than the conventional, and by how much? How much pa?
Uh, Actually, for this question, no, the design I show is the initial design. So this anaerobic digester po na that I showed is currently uh, under research po. So this is funded by DOST din, which is kakasimula lang po this year. So under research po or nag-experiment pa po kami on by how much po yung yung kung gaano kabilis po or what is the difference between the conventional digester that produce methane compared to our uh, design or our research. So ano pa po siya, under construction pa po, and since hindi pa po buo yung prototype namin, it's nasa design pa lang po. So once the prototype has been fabricated and tested for methane fabrication, pa lang po natin masasabi on how much po yung napoproduce na methane nitong design po.
Yun, thank you po. Maybe perhaps this is a good way also to partner with, since nasa ano pa lang po kayo, design stage or prototyping.
Yes po.
People, they could also partner, collaborate with you to develop pa po further po or in the research. Maybe with the industry or the other academy. Okay, thank you very much. So we have another question from an anonymous. This could be for Sir Kenon. Good morning. Ako kasi personally, I use SolidWorks. May I ask what are the differences between the two programs? Thank you. I believe you're a previous user of that program.
Okay, so the difference between the two programs is the synchronous technology of Solid Edge. So in SolidWorks, so you have to create a sketch and you have to dimension the sketch in order to create a part. So in Solid Edge, you don't have to create a sketch. You can directly create a part and you can dimension directly on the part. So hindi mo na kailangan bumalik pa sa mga sketches mo to parametrically change the dimensions and different geometry, no? And the good thing in Solid Edge 2023, so yung synchronous technology, so kung nasanay ka sa sketch muna bago ka gumawa ng feature, so in Solid Edge meron din nun yung tinatawag na ordered modeling. So in ordered modeling, you can use the feature na present kay synchronous like yung auto region detection and yung steering wheel na nakay synchronous present na rin siya kay ordered. So in Solid Edge, you can create a model using synchronous technology. Yung pangatlo is hybrid combination of synchronous and ordered.
All right, thank you very much. So that synchronous technology is what really separates, no? Kasi of the usage and the time to create a model, it's very helpful in the. So thank you. So another question po for Engineer John. So sabi tanong dito, is there any research regarding the collection of energy in lightning thunder? Mga kulog. You can energy from kulog or kidlat.
Yes po. Sir, with regards po dito sa collection of energy in lightning or thunder po, no? Excuse me. Actually, may mga ilang literature na po ako nabasa, but here in the Philippines, hindi pa po siya, I think wala pang nag-i-introduce ng ganitong research sa Philippines since since hindi na napaka-random po kasi ng thunder. But may inaaral po ako ngayon which is a part of a proposal din sa akin wherein yung electricity from the air can be harvested and turned into electricity. So, the higher the elevation, mas maraming ions or ions na active ions na pwede nating i-harvest and can be turned into electricity. So, medyo pinag-aaralan ko pa on how we can go beyond that process, the harvesting process ng ions in the air.
Okay, thank you very much. That would be very safe, no? Because air is everywhere naman eh. And that is safer than the thunder and kidlat na paminsan-minsan. I don't know how it is being...
Also, if you're...
Yeah. So, thank you po. This is for Engineer Ken, Mr. Ricky. My question is, the solid edge material is applicable to AutoCAD or can work convert with AutoCAD? Can it work with AutoCAD browser or is it applicable to AutoCAD? Parang ko kanina, sir, 2D to 3D.
Okay. So, I forgot to mention earlier po no, na the legacy data that I use to convert 2D to 3D is a AutoCAD drawing file. So, yes, direct open lang si AutoCAD drawing file sa Solid Edge. And yung second part naman, which is the SolidWorks din yung sa 3D import data kanina. So direct open din siya kay Solid Edge. So AutoCAD and SolidWorks direct open lang po kay Solid Edge.
Okay, thank you very much po. So siguro last na lang po ito, no. Hello po, Engineer Jhon. I'd like to inquire also if you are aware about a research. I think in Japan that they are trying to get energy from carbon dioxide. Since we are trying to study different resources, do you think it can be a...
Yes, I think this is also applicable in the Philippines since we have many industrial plant and marami siyang byproduct ng carbon. So one of the researches related to this is yung different processes in carbon capture. So once na yung carbon is makuha natin from our byproduct, it can be captured and stored and convert it into fuel. So I think that is the research or study in Japan. And siguro I'm not familiar kung may gumagawa na nito sa Philippines, but I think this is also a good research and also applicable here in the Philippines since may marami din tayong industrial plants where we can have the sources of that carbon that we need for this research.
Okay, thank you very much po. So we don't have that much time na po and hopefully po some of the industry can be able to reach out to you, Sir Jhon, so that they can also perhaps partner with you para po to develop more energy. So let's proceed po for our next part. Thank you very much. So here in Stanford IT Learning po, so it is our mission po to help schools, universities, colleges to really further develop yung ating mga teachers and students to be industry ready. So by providing them with the proper training industry software tools. So you've already seen that, the technology, and of course the technical support that we're going to provide. So we're running a 30-day promo period for our academic adoption program. It's a 50% off. So the program includes the software to be used by the faculty, students, solid edge training po. We are providing you the training to accelerate your knowledge, the use of solid edge. And of course, yung ating Siemens certification exam na sinabi kanina ni Engineer Kenon, and we also provide the deployment and installation po of the software. Of course, the consultancy and the technical support. So for those who are really interested, so please reach me at that screen, the number and my email. Okay, you can even have a screenshot of this page. Feel free to message for any inquiries. Thank you. Next. Ayan, so may nagtanong kanina, no? So feedback form. So here po, those who want to get their feedback and of course yung ating e-certificate, so please no, scan the QR code, and also I hope that the links will be provided as well on the chat. You can also yeah, thank you very much, Erica, for sharing. So please feel free, no? Next. So we are also inviting you to our another event. So nabanggit na kanina ni Engineer about the new version, Solid Edge 2023. So this will be on December 6 at 2 p.m. So via Zoom. So we also provide you the registration there. There you go. Thank you. Next po. Yan. So also na-mention na rin kanina ni Kenon. So we also have our Solid Edge user group. To those who would catch a replay this webinar, we'll post it there in the user group. We'll also post other very relevant topics related to Solid Edge, industry, best practices perhaps, ating mga collaboration with the schools and the industry. So of course, it's really to help you know maximize the use of the software, and we encourage you to join, and please scan the link and the QR code and the link provided at the chat box. Okay, let's go to our the raffle. Hopefully you are able to dali lang, hindi ako marinig. So for our first question, I don't know if you can hear me. Naririnig ba? Dali. Can you music? Can you turn off the music? So para sa ating first question, ito po yung question, no? Nabanggit kanina ni Engineer Kenon. So ito siya, it combines no yung strengths ng history-based at direct modeling approach. Ano po ang tawag dito sa technology ng solid doon sa ibang software? May binanggit kanina, Q&A. It start with letter S. Ayun, meron na. So synchronous technology. Yan. Synchronous is valid ba siya? Okay ba siya? Sige po. So I'll just leave that to our marketing. Sino po yung maging winner. And then for our second question, yeah, Reynaldo. Congratulations. So our next question po, so it is basically, it is a portfolio covering all the aspects of our product lifecycle management. It also covers the product design, mechanical, electrical simulation, product manufacturing, and product performance collaboration, na including yung IoT. So ano po yung tawag dito sa sa platform na ito na it start with actual letter X? Oh, meron na. Ayan. So I'll just leave it to the... So I would like to congratulate po yung kaninang nanalo, si Abigail Villalon, si Ariel Glorioso, and si Miss April Marcelo, at ngayon po yung si Reynaldo, and also the last one is Hans ba? Yan. So for you to get po yung just have your email, you'll be contacted by our marketing through your phone or your email po. So we would like to thank you to everyone who attended, and we would like to invite you and subscribe to our FB page. Please contact us at our email address, phone number. If you have any suggestion po, maybe you can also share, just like Engineer Jhon. Feel free po. So let us help our country engineer a better place. So thank you and God bless.